This is Pre-Calculus B, Unit 3, Lesson 6, Trigonometric Equations. I have a problem on the screen. This is a problem of a class known as Rectilinear Motion. Basically what's happening here is we're modeling, in this case, the height of a passenger on a Ferris wheel. A Ferris wheel, of course, travels in a circular path, but if we model just the height component, we can be thinking of the person is moving up and down and up and down and up and down, rather than considering the left and right motion. Okay? This particular sinusoidal function models that behavior. It basically says, here we go, we've got a center of movement, or a center of oscillation of 14. Okay? So if, let's see if I can do a scale drawing. If this is the ground, 2, 4, 6, 8, 10, 12, 14, just counting by twos here, right? And the amplitude is 10, so 2, 4, 6, 8, 10. So it looks like the height never gets down to 0, right? And 2, 4, 6, 8, 10. Okay, and so 24 and 4, and the units are meters, so it starts at a height of 4 meters, goes up to a height of 24 meters and back down and up and down and up and down and up and down. Okay, so that's kind of what's going on. Here, let me model the Ferris wheel portion of it here with a cycle. A cycle, eh? Yeah. All right, so there we go. Right? Now the question that's being asked is when does the height of the passenger get to 20 meters? Now this is a cyclical thing, so it repeats itself over and over and over again. Okay? But when does it reach a height of 20 meters? Well, we can tell from the graph where it reaches a height of 20 meters. Let me draw a white line here. Okay, 14, 16, 18, 20, right here. Right here. So in the first rotation, it's going to reach a height of 20 meters right here. Okay, and the question is, when will that be? Now we can see, hopefully fairly clearly, that it's going to reach a height of 20 meters on the way back down as well, and that would be a different result. Okay, but the question's asking about when it first reaches 20 meters. So we're really after the time aspect right here. Now at t equals 0, it's going to be starting at negative pi over 2. So the sine rotation here is going to be straight down. And so basically we're asking for, and I'm just clarifying the problem here, we're asking for how long it'll take for the Ferris wheel to travel this path. Okay? All right. To end up right here at 20 meters. Okay? To do that, it's simply a matter of solving this equation. H of t equals 20 meters. When does h of t equal 20 meters? Well, h of t is 10 sine 3t minus pi over 2 plus 14, and that's got to equal 20. Okay, let's subtract 14 from both sides. 10 sine 3t minus pi over 2 equals 6. Divide by 10. Sine 3t minus pi over 2 equals 6/10 to 0.6. Okay, and now we come to the interesting part of the problem. Arc sine. You have to consider what is the domain of arc sine. 3t minus pi over 2. Arc sine is the inverse sine. So we're going to say arc sine of 0.6. Okay, there's an arc sine that's going to return this value, this angle theta right here, right? And that's what it's going to return. But you have to consider in the context of the problem, which value is it that we really are after? Are we after the primary value? Are we after the secondary value, or some other value? Because we can also add 2 pi to it, right? Well, in this case, the primary will do, because the range of sine is between between 0 and pi. Actually, it's between negative pi over 2 and pi over 2. Yeah. But this is less than, well, it'll work. All right, so let's go ahead and add pi over 2 to both sides. 3t equals arc sine 0.6 plus pi over 2. Yeah, the answer lies in the fact that we're looking for the first time it reaches that, not the second. Okay, and divide by 3. You can distribute division just like you distribute multiplication. So actually, let's do this. 1/3 arc sine 0.6. Pi over 2 divided by 3 is pi over 6. Okay, and I write it like this because I want to leave the answer exact as long as I can. Plus, it allows me to enter it on my calculator all at once and eliminates the chance that I will have round-off error. Okay, when you do the calculation in parts, in pieces, and then you round off at each step, the error of that round-off gets multiplied and can grow. So it's best to express it as one final expression that's entered on the calculator. So arcsine, A-R-C-S-I-N in Desmos, you can use the keyboard icon to show keyboard and select the function arcsine with a little -1 as well. I find it easier to type arcsine. 0.6 plus pi over 6. Now, a reminder, anytime we're dealing with sine, cosine, and tangent, or their inverses, got to check and make sure we are in the right angle measure. And we're measuring in radians. And as soon as we are dealing with pi's, chances are we're talking about radians. And the default is radians. Okay, so it looks like t is about 0.738. All right, 0.738. Now this is minutes. Okay, and here's the hint. The ride lasts for 5 minutes. And the t is expressed in minutes, but they want this answer expressed in seconds. So t is approximately equal to 0.738 times 60. Let's do it this way here. I'm going to just say t equals, and then do 60t. And I get 44.2859. Doesn't say what we wanted to round to. So 44.29. 44.29 seconds. Rounding to the hundredths place. Okay, so about 2/3, almost 3/4 of a minute. Okay, so hopefully that helps.